Hello everyone. Today I am here to discuss about the electromagnetic spectrum. After studying this lecture, you shall be able to know what is electromagnetic spectrum and its properties, understand the relationship between the wavelength and frequency of different types of radiations, know regarding the uses, advantages and disadvantages of electromagnetic radiations, and know the basic terminology like frequency, wavelength, wave number, energy used in electromagnetic radiations. What is electromagnetic spectrum? The electromagnetic spectrum is the entire range of electromagnetic waves in order of increasing frequency and decreasing wavelength. Means the electromagnetic spectrum is a continuum of all the electromagnetic waves arranged according to the frequency and wavelength. In the electromagnetic spectrum, as we go from left to right, the wavelength gets smaller and the frequency gets higher. Means there is an inverse relationship between wavelength and the frequency. That is, one goes up and other goes down. This is because the speed of the electromagnetic wave is the speed of light. As we know about the electromagnetic spectrum, we also know about the properties of the electromagnetic waves. The higher the frequency, the more energy the wave has. Electromagnetic waves do not require media in which to travel or move. Electromagnetic waves are considered to be a transfer waves because they are made up of vibrating electric and magnetic fields at right angle to each other and to the direction the waves are traveling. As the wavelength gets smaller, frequency gets higher. This indicates the inverse relationship between wave size and frequency. In spectroscopy, electromagnetic radiations are used as a radiation source. There are 7 types of electromagnetic radiation like radio wave, microwave, infrared, visible light, ultraviolet radiation, X-rays and gamma rays which are used in spectroscopy. In this table, we can see the wavelength in angstrom, wavelength in centimeter, frequency in hertz, and energy in electron volt. Now, we will consider one by one electromagnetic waves. First, we take radio wave. Radio wave in the electromagnetic spectrum that have the longest wavelength and lowest frequency are called radio wave. Wavelength ranges from thousands of meter to 0.001 meter. Radio waves are used to transmit information from the antenna of the broadcasting station to the antenna of your radio or TV. In astronomy, the radio waves are used to gain information from the distant stars using radio telescopes. Radio telescopes have the advantage that the radio waves are not blocked by the condition of Earth's atmosphere as the light waves are. Radio waves are used in radar, cooking food, and satellite transmissions. Next is microwave, the highest frequency of the radio wave. Their wavelength is only a few centimeters long. While microwave pass right through some material, other absorbs them. Water and some other molecules found in the food absorb microwave and turn the energy into heat. This is what makes a microwave oven work. Glass and plastic do not absorb microwave, so they do not heat up. Metal absorbs microwave, so we can't put it inside a microwave oven. Short wavelength microwave are used in radar devices. Radar work by sending out short pulses of radio waves and recording the time it takes for the reflecting wave to be picked up by the receiver. Next is infrared waves and the visible light. Infrared light lies between the visible and microwave portion of the electromagnetic spectrum. Shorter, near-infrared waves are not hot at all. In fact, you cannot even feel them. Its shorter wavelength from 0.001 meter to 700 nanometer and therefore a higher frequency. These shorter wavelengths are the one used by your TV remote control. Far IR waves we experience every day in the form of heat. The heat that we feel from the sunlight, a fire or a radiator. Now we discuss about the visible light. Wavelength ranges from 700 nanometer, that is red light, to 30 nanometer, that is violet light, with frequency higher than the IR waves. These are the waves in the electromagnetic spectrum that the human can see. Visible light waves are a very small part of the electromagnetic spectrum. Visible light waves are the form of electromagnetic radio waves such as IR radiation, X-ray, microwave and ultraviolet radiation. We can see these waves as the color of rainbow where each color includes a different wavelength. Red has the longest wavelength and violet has the shortest one. When all the waves can see together, they form a white light. When the white light comes through the prism, it gets broken into the colors of the visible light spectrum. Electromagnetic radiation can transmit in waves or particles at different frequencies and wavelengths. It is divided into 7 areas like red, orange, yellow, green, blue, indigo, violet in decreasing order of wavelength and increasing order of the energy and frequency. Next is ultraviolet light. Ultraviolet light is a radiation with a wavelength shorter than that of the visible light but longer than the X-rays in the range of 10 nanometer to 100 nanometer. Though these waves are invisible to the human eye, some insects like bumblebees can see them. Ultraviolet on our skin produces vitamin D in our bodies. Too much ultraviolet can lead to sunburn and skin cancer. UV rays can easily be blocked by clothing, but it is used for sterilization to kill bacteria. Next is X-rays. X-rays having smaller wavelength, that is 10 nanometer to 0.001 nanometer and therefore higher energy than the ultraviolet waves. We usually talk about X-rays in terms of their energy rather than wavelength. X-rays are the most known for their use in medicine. Because of your bones and teeth are dense and absorb more X-rays than your skin does, images of your bones or teeth are left on the X-ray film while your skin appears transparent. X-rays are highly used in the treatment of the cancer. Now, last is gamma rays. Gamma rays carry the most energy and have the shortest wavelength less than the 1 trillionth of the meter, that is 10 to the power minus 12. Gamma rays have enough energy to go through most materials easily. You would need a 3 to 4 feet thick concrete wall to stop them. Gamma rays are released by the nuclear reactors in the nuclear power plants, by nuclear bombs, and by naturally occurring elements on Earth, sometimes used in the treatment of the cancers. Now, we will discuss some basic term of electromagnetic radiation, that is wavelength. Wavelength, it is a difference between two crusts and the two trough is wavelength. It is represented by the symbol lambda and the unit of the wavelength are angstrom or nanometer. Next is wave number. Wave number, it is a number of waves passed through a space of 1 centimeter. It is a reciprocal of wavelength and it is measured in a unit centimeter inverse. The formula of the wave number is 1 by wavelength. Frequency, it is the number of waves passed through a point in a duration of 1 second and it is measured in a unit hertz or second inverse. The formula of the frequency is inversely proportional to the wavelength, or frequency is equals to c by lambda, where c, it is the constant or velocity of the electromagnetic radiation. The value of the c is 3 into 10 raised to power 10 centimeter inverse. And last is energy. Any electromagnetic radiation having some energy which is represented by the symbol E. Formula of the energy is h nu, or E is equals to h c by lambda. Now we will discuss some numericals. Number 1, calculate the wave number of 2.5 micron wavelength. So in this numerical, we calculate the wave number having a formula 1 by wavelength. We put the value of wavelength and get the answer in centimeter inverse. Next question, calculate the frequency for 3800 angstrom, where we calculate the frequency having a formula C by lambda. The value of C is already given, that is 3 into 10 raised to power 10. Put the value of lambda and get answer. Next, calculate the energy for 3800 angstrom wavelength. So in this numerical, we calculate energy having a formula h c by lambda. Put the values, because h is constant, c is constant, and the value of lambda is given. So we get the answer in earth. These are the some image sources which is used in our PPT. And these are the references. Thank you.